Hello students, welcome to Soros's classes. This video is Infinite Series Part 6. Now let us start this video with comparison test. If there are two positive term series, positive term series summation un and summation vn be such that limit n tends to infinity un divided by vn is equals to k, that is a finite number, then both the series converges. Both the series converges or diverges together. Or both the series converge or diverge together. Now let us prove it. By the definition of limit, there exists a positive number epsilon, however small, such that mod of un divided by vn minus k is less than epsilon for n greater than m. So by definition of limit, there exists a positive number epsilon, however small, such that mod of un divided by vn minus k is less than epsilon for n greater than m. This implies k minus epsilon is, or un divided by vn is greater than k minus epsilon and less than k plus epsilon for n greater than m. So ignoring the first m terms of both sides, first m terms of both sides, we have un divided by vn is less than k plus epsilon and it is greater than k minus epsilon for all n. Now case 1, let vn is convergent. Therefore, limit n tends to infinity v1 plus v2 plus so on plus vn is equals to h, where h is some finite number. Now let us denote this equation as equation 1. Now from equation 1 we have un is less than k plus epsilon into Vn. This implies u1 plus u2 plus so on till un is less than k plus epsilon into v1 plus v2 plus so on till vn. Then limit n tends to infinity u1 plus u2 plus so on till un is less than k plus epsilon into limit n tends to infinity v1 plus v2 plus so on till vn, which is equals to k plus epsilon into h. Hence, limit n tends to infinity u1 plus u2 plus so on till un is less than k plus epsilon into h. Hence, the series un also converges. The series of summation un is also a convergent series. Now let us consider that our series summation Vn is divergent. Then limit n tends to infinity v1 plus v2 plus so on till vn. This tends to infinity. Now again, from equation 1 we have un is greater than k minus epsilon into Vn. So this implies u1 plus u2 plus so on till un is greater than k minus epsilon into v1 plus v2 plus so on till vn. Then limit n tends to infinity u1 plus u2 plus so on till un. This is greater than k minus epsilon into limit n tends to infinity v1 plus v2 plus so on till vn. Now we have previously said that limit n tends to infinity v1 plus v2 plus vn, this tends to infinity. Hence, if we note it as equation number 2 and this as equation number 3, then from equation 2 and 3 we can say that limit n tends to infinity u1 plus u2 plus so on till un, this tends to infinity, and hence summation un is also divergent series, and hence both the series converges or diverges together. For testing of convergence of a series, this comparison test is very useful. Now if we choose a series summation Vn such that limit n tends to infinity un divided by Vn is equals to some finite number, then nature of both the series is same. So if the nature of series Vn is already known, then from this we can also find out the nature of series summation un.